So let's start with the conditional probability. Okay.
Yeah, sir.
Yeah. Just a second. I'm just adjusting this. Yeah. Let's start with the conditional probability. So define and calculate a conditional probability. Conditional probability is one where the occurrence of one event affects the probability of the occurrence of other. Okay. That means clear cut probability of A given B has already occurred. So probability of A given B has occurred. That means you will carry umbrella only if rain is occurred. Okay. Or rain is happening outside. Okay. So your carrying of umbrella solely depends upon the falling of rain, okay, or the occurrence of rain outside. Am I right? Your carrying of umbrella solely depends upon occurrence of rain outside, or the insurance company giving the reimbursement, okay, on an accident case only if the accident has occurred. So the reimbursement or umbrella, you can take it as an example. So the reimbursement will be given, okay, given that the accident has occurred. So condition is nothing but happening of this solely depends upon happening of this. If this happen, this will happen, or else this won't happen. Accident has occurred. Umbrella, you will carry the umbrella only if rain has occurred. Unconditional probability refers to probability of an event regardless of past or future occurrence of other event. That means like it is a normal probability. Okay. If we are concerned with the probability of an economic recession regardless of occurrence of changes in interest rates or inflation, we are concerned with unconditional probability of a recession. That means if we are concerned with probability of an economic recession, that means if I say about unconditional probability, that will not that doesn't depend on the other like event. Okay, for example, you that means you like uh, going to a library, okay, is not dependent on what. Not dependent on, like, how come we can correlate this? There shouldn't be any kind of relationship. You going to a library doesn't depend on you going to a theater. Am I right?
Yes, sir.
Your going to
Yeah.
library doesn't depend, or like you will go to a library given that you are going to a theater. No, it has no relationship. You going to a theater and you buying a ticket is definitely conditional probability. That means dependent probability. So
Yes.
your buying of a ticket solely depends on you going to a theater. Am I right? Now, joint probability. Joint probability mein what will happen? This is like umbrella, and the rain is falling. So this is joint probability. Okay. So A intersection B, we have done already in the Bayes theorem. So probability of A given B has occurred is nothing but probability of A intersection B by probability of B. That means probability of A into B or A intersection B is probability of A given B has occurred into probability of B. This is the formula. We have already done in the base theorem. So यहाँ तक सब clear है. We'll go forward. Why don't you do this question? ये question solve करो. I'll go for the next one. Solve this. I'm giving the time. Are you solving?
Yes, sir. Yeah, doing it, sir.
Yeah.
Yes.
Yeah. So you understood now what is happening here? Probability of monetary authority increasing interest rates is this, and the probability of recession, given that like probability of recession happening, given that monetary authority has increased the interest rates 0.7. Okay. And like joint probability is what, like recession has occurred, and like given that the monetary authority has increased the interest into the increment of the interest. Okay, this is the prior probability. What is the prior probability? The interest rates have increased. Okay, because of that, the probability of recession. Okay, the probability of monetary authority increasing interest rates is 40%. The probability of recession given an increase in interest rates is 70%. So the recession has probability of recession occurring given that the monetary authority has increased interest rates. Okay, that has already occurred. So here we are seeing the joint probability. That means recession and interest rates are happening commonly, and for that the formula is for the joint probability, that is probability of R intersection I. The formula is R happening given that I has occurred into probability of I. That's it, 28%. Independent events I've already explained you. Happening of one doesn't is not dependent on happening of another. Like you going to library and you going to theater, there is no relationship. Okay, those are independent events, and mutually exclusive are happening of one. Okay, will prevent the happening of another. Uh, like uh, like falling of head will prevent the falling of tail. Why? Because two at a time cannot happen, only one can happen. So that is mutually exclusive events. So independent I've already explained you here. Refer to events for which occurrence of one has no influence on occurrence of others. The definition of independent events can be expressed in terms of conditional properties. Events A and B are independent if and only if probability of A given that B has occurred is equal to probability of A. There is no joint probability here. Is there any joint probability? No. So this is independent, this is independent. If this condition is not satisfied, the events are dependent events. If probability of A given that B has already occurred is equal to probability of A, that means happening of A has nothing to do with happening of B. Happening of A is happening like that. It is not dependent on B. So there is a case, clear cut chance that it is a independent event, not a dependent event. Okay. Probability of A given that B has already occurred is equal to probability of A and B divided by probability of B. That is dependent event. Okay. We already seen that. Conditional probabilities. In our interest rate and recession example, recall that events I and R are not independent. The occurrence of I affects the probability of occurrence of R. In this case, the independent conditions for I and R are violated because R is 0.34, and this is so probability of recession is greater than there is increase in interest rates. So the best examples of independent events are found with probabilities of dice tosses or coin flips. A die has no memory. Therefore, the event of rolling a 4 on second toss is independent of rolling a 4 on the first toss. So yeah, your second toss 4 is not dependent on your first toss 4. That means you getting 4 in the second toss does not depend on you getting 4 in the first toss, because they are two different things. Anything can fall. Okay. So probability of 4 on second toss, given that 4 on first toss is probability of 4 on second toss. That means it doesn't, the happening of this doesn't depend on happening of this. So here we are like probability that at least one or two events will occur is nothing but P of A or B. Okay, you know, at least one, either A or B, either A, at least one of two events will occur, either A or B. That is probability of A plus probability of B minus the common thing we are removing from that. So we are getting the probability of at least A or B. So mutually exclusive events like happening of one, what we say, so are where the joint probability is 0. That means like both of them cannot happen at a time. Okay, that is mutually exclusive. If you toss a coin, if you get a head, okay, uh, like uh, like head can fall, then there is the clear cut case that tail will not fall. Okay, both the things will not happen at a time. So probability of A intersection B is always 0 in mutually exclusive events. So here we are, probability of A intersection B is 0. That means it is a mutually exclusive event. What is mutually exclusive? Happening of one will prevent the happening of another. That means only one can happen. You can't do both at the same time. Okay, both of them cannot happen at once. Things that can't happen at the same time, so like disjoint, or those are mutually exclusive. That means if head falls, tail cannot fall. Falling of head will prevent the falling of tail. Okay, that means two things cannot happen at one time. Mutually exclusive means you have to pick one from the given options you have. So like P of A, P of B, these are two independent ones, and this is like probability of A intersection B is joint event. Okay, so Venn diagram for the events that are not mutually exclusive, because P of A intersection B is existing. If this is not there, then those are mutually exclusive. That means if P of A intersection B is equal to 0, then it is mutually exclusive. Why? Because two of them cannot happen at a time. Head and tail cannot fall at a time. If head falls, tail will not fall. Okay, happening of one will prevent the happening of other, or two of them cannot happen at a time, at once. So you have a question here. Using the information in the previous example, this is a probability of recession. Determine the probability that either interest rates will increase or recession will occur. Either this or that. That means P of A or B. Okay, so P of A plus P of B minus P of A intersection B. This is like given. They are saying you have to find either, at least one should happen. Either interest rates will increase or recession will occur. So at least one happens is nothing but from them, from any of them, from both of them, only at least R can happen or I can happen. Okay, okay, but both cannot happen. That is A intersection B cannot happen, should not be that. A intersection B is both are common actually. Okay, so if I want to find either R happens or I happens, I have to go for union. So this is the formula for union. We are removing the common out of them. Okay, so this is either R or I can happen. Calculating a joint probability of any number of independent events. Joint probability is nothing but A intersection B. Okay, so you already know that joint probability is A intersection B. Let us see an example. So what is the probability of rolling 3 4s in one simultaneous toss of 3 die? So the probability of rolling 4 for each die is 1 by 6. So you multiply all of them. So similarly, probability of 4 heads on flip of 4 coins. So 4 coins you are flipping and 4 heads 1 by 2. So it is like 0.0625. joint probability of more than two independent events. So using this is joint probability of more than two independent events. So what is the probability of rolling 3 4s in one simultaneous toss of 3 dice? And here we have seen this example. Next example is using empirical probability. Suppose we observe that DJIA has closed higher on 2/3 of all days in past few decades. So furthermore, it has been determined that up and down days are independent. Based on this information, compute the probability of DJIA closing higher for 5 consecutive days. So DJIA up 5 days in a row. So what is this DJLA or what was this? DJLA up 5 days in a row. D what is the probability closing higher for 5 consecutive days? Which example is this actually? This is connected with some example. रूम से बाहर जाओ रूम से बाहर जाओ नाउ joint probability for more than two independent events using empirical probabilities. Suppose we observe that DJIA has closed higher on 2/3 of all days in past decades. This is some stock. What is this? LA or IA? That's what DJIA is, some index maybe. Just a second. Dow Jones Industrial Average. Fine. So they are saying using empirical probability, suppose we observe that Dow Jones Industrial Average has closed higher on 2/3 of all days in past decades. Okay, higher of 2/3, and 66.6%. So higher of 2/3 in past few decades. So furthermore, it has been determined that up to 2 days that up and down days are independent. So based on this information, compute the probability of Dow Jones closing higher for 5 consecutive days. So the probability of Dow Jones closing higher for 5 consecutive days is like what they have said, that it has closed 2/3 of all days in the past few decades. So we'll say 2 by 3 5 times. So this is what. Similarly, down 5 days in a row, if it is like 2 by 3, that is for up, then 1 by 3 is for down, because the sum of the probabilities is always equal to 1. That is probability of success, that is up, and probability of failure, that is down. Up and down is equal to 1. So for up, whole power 5, for down, this. That's what. These are independent events actually. So this is also finished. Last and final concept of the chapter, probability matrix. So please go through this concept. I'll be back in a second. Please read this. You have to solve this question. I'm giving you time, okay? We'll discuss and wind up. 5 minutes. Yeah. Hello. Yes.
समझ में नहीं आ रही.
Yeah, no problem. See, given the following incomplete probability matrix, calculate the joint probability of a normal economy and an increase in rates and the unconditional probability of a good economy. So good, increase, no increase here. So you have to just match it. 15 plus x2 is equal to x3. Okay. And x1 plus 25 is equal to x4. So 10 plus 20 is 30. So here 50, 15 and 10 is how much? 25. 50 minus 25 is 25. Is it so? Correct है कि wrong है? Correct है कि wrong है boss?
Correct है sir.
हाँ. So आपको इसका आंसर आ जाएगा ना? ये 15 है, ये 10 है. 50 minus 10 minus 15 is 50 minus 25 is 25. 50 minus 45 is 5. Correct है कि wrong है?
Yes sir.
50 minus 45 is 5 and 15 plus 5 is 20 and 25 plus 25 is 50. 20 plus 50 is 70. 70 plus 30 is 100. ठीक है? After getting
Yes.
everything, given the following incomplete probability matrix, calculate the joint probability of normal economy and an increase in interest rates. तो normal economy का ये आएगा, increase in interest rates क्या आएगा? ये आएगा. तो आपको उसका joint probability लेना पड़ेगा.
हाँ सर.
तो बट उसने कुछ नहीं है, उसने तो पूरा फाइंड कर लिया है बस. He has found out the x1 and x2 x3 all this we have also found out. That's it, finished. उतना ही है बस उसने और क्या फाइंड किया. मतलब joint probability, how will you get joint probability? It's very simple to understand ना. This row and this column where they are, this C, this is the row na, this is the
Yes sir.
column. Will you believe or not?
Yes sir.
So this row shows the increase. Okay. So what are they asking? Given the following incomplete probability matrix, calculate the joint probability of normal economy. This is normal economy and an increase in rates. So increase in rates also you're getting. So for a normal economy, which is row, increase in interest rates is column. It's nothing but 25%. Got it?
Yes sir.
And the unconditional probability of a good economy. So good economy means there's no condition. So this is x2. So you'll get 5%. Okay, that's it. Done with the chapter. Tomorrow we will do distributions. Okay.
Yes sir.
Yes, Chandra, are you?
Yeah, sir. Listening, sir.
Yeah, we will do distributions tomorrow. Okay.
Okay,
And
sir.
Chandra, I will take a separate class for exchange rates for you. Is that okay, or we'll do distributions only tomorrow?
Okay, sir.
What shall we do? Only distributions or exchange rates tomorrow?
As for you, sir.
No. I'm asking. Both the
Exchange
chapters
rates, sir.
require or one chapter is okay?
Yeah, we can do both at a time.
Okay, then afternoon I'll
Sure.
take exchange rates for you.
Yeah,
One
sure,
chapter
sir.
and evening distributions. Fine.
Okay, sir. Yeah.
Chalo. Bye.
Bye, sir.
Acha, Chandra, I will inform you the time in the morning.
Yeah, sure, sir.
By 11:30 about the exchange rates. Okay.
Okay, sir. Okay.
And this will be in the evening itself. Yeah.
Okay,
Bye.
sir. Yeah. Bye.
Good night.
Sir.